Hi everyone. So today I'll be taking a look at Unit 4, Notes number 8, which covers midsegments and perpendicular bisectors. A midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle. So if you take a look at this triangle below, you can estimate where the midpoints would be. So if we take a look on line segment AB, and if I call that midpoint D, and take a look at line segment AC and refer to that midpoint as E, then this segment would be the midsegment. DE would be a midsegment. Now, to identify those points as midpoints, you're going to want to take a look at the diagram and look for markings. So by marking those segments congruent on either side of those points, that's indicating that point D and point E are midpoints. Now, every triangle has three different midsegments because you can find the midpoint of each of the three sides. So this would be point F, the midpoint of line segment BC. And again, we would have to know that BF and FC are congruent. So you could connect E to F, and that would be a midsegment. And you can connect D to F, and that's also a midsegment. So the midsegment theorem says the segment connecting the midpoints of two sides of a triangle is parallel to the third side. That's an R in there. And is half as long as the third side. Now, you probably could have guessed from my sketch that it would be parallel. But the length piece, you just have to memorize the theorem. Okay, so we're going to write down a few relationships here. DE, that midsegment, is parallel to BC. And according to the midsegment theorem, DE, the length of it, so no symbol above it, is equal to 1/2 of BC. That also means that BC is equal to 2 times DE. If you double the midsegment, it gives you the length of the third side. Now we can continue going around the triangle. EF is another midsegment, and EF would be parallel to AB. And likewise, EF would be 1/2 the length of AB. And again, you can turn that around and say that AB, that third side, is equal to 2 times EF. So if you double the midsegment, you get the length of the third side. All right, finally, we have one more midsegment from D to F. So that's going to be parallel to AC. And again, the midsegment DF will be 1/2 of AC. And again, we can switch it around and say that 2 times DF is equal to AC. And you're going to want to know these relationships so that you can set up and solve equations. All right, in our first example, it says in triangle ABC, points D, E, and F are midpoints. So D is the midpoint of this side, E is the midpoint of this side, F is the midpoint of this side. Okay, so that means that FD is a midsegment. So FD will be parallel to the third side, AC. EF is another midsegment, and that's right here. And so it's going to be parallel to BC. All right, so now for some relationships and figuring out different lengths. So it says if FD is equal to 8, so I come in here, and the midsegment has a length of 8, then this side has to be 2 times that. Okay, because the midsegment is half the length of the third side. So half of 16 gives us 8. So AC must be equal to 16. All right, likewise, on this side, if they tell us that BC is 32, and they're asking us to find the length of EF, EF is the midsegment. It has to be half of that. So EF would be 16. All right, final question. Let me clean this up just a little bit here so you can see everything. It says FD is equal to what other two segments? Well, since FD is the midsegment that compares to AC, and FD is half of AC, that means that FD must be congruent to AE and EC. So you can fill in the blank here. It's not a lot of room, but we can squeeze it in there. AE and EC, because AE and EC are both 1/2 of AC, and FD is half of AC as well. All right, in example 2, we're going to get into some algebra. And it says in triangle JKL, MN and O are midpoints of the sides, and that establishes the fact that MN is a midsegment, and so are NO and MO. Right. In part A, it says if MN equals 3x plus 8 and LK equals 2x plus 24, what is MN? Well, keep in mind that MN, being the midsegment, means that it's going to be equal to 1/2 of the length of line segment LK. All right, so we're comparing MN to LK. Obviously, they're not equal to each other, but according to the midsegment theorem, the midsegment's half as long as that third side. So we're going to take and plug in 3x plus 8 for MN. That's an 8 over here. And then we're going to set it equal to 1/2 of LK, which is 2x plus 24. So we have a little bit of algebra to do. So I have 3x plus 8. Now you have to distribute that 1/2. 1/2 of 2x is just x, and 1/2 of 24 is equal to 12. And I'm going to continue this over here. So we have our equation 3x plus 8 is equal to x plus 12. So take and subtract x from both sides. I get 2x plus 8 is equal to 12. Subtract 8, and we get 4. So 2x is equal to 4. Therefore, x is equal to 2. Okay, now watch out because usually there's a follow-up question. So we solved for x, but we have to find mn. Now remember that mn was equal to 3x plus 8. We just found that x was equal to 2. So plug 2 back in. 3 times 2 equals 6. 6 plus 8 equals 14. Okay, with our second example, it says if MO is equal to 3y minus 5 and JK is equal to 4y plus 2, what is JN? So be careful here. All right, so the relationship between MO and JK is that MO is the midsegment, so it has to be half the length of line segment JK. And again, if you find working with the fractions a little bit tricky, then you want to double the midsegment, take 2 times MO, and set it equal to JK. So let's try it that way for this one. So do 2 times MO, so 2 times 3y minus 5, and set it equal to JK, which is 4y plus 2. Distribute the 2, and we end up with 6y minus 10 equals 4y plus 2. Take and subtract 4y from both sides, and you end up with 2y minus 10 is equal to 2. Let me just scoot this up a little bit. And keep going. Add that 10 to both sides, and we get 12 on the other side. So if 2y is equal to 12, then y equals 6. Okay, so keep in mind though, we have to find the length of line segment JN. So if y equals 6, let's start with finding JK. So JK was equal to 4y plus 2. So we're going to plug in that 6 for y. So you get 6 times 4 is 24, plus 2 is 26. Now that's the whole length of the third side, JK. JN is half of that because n's a midpoint. So final answer for JN is 13. 26 divided by 2 is 13. Okay, another special segment is the perpendicular bisector of a segment. So if we take a look at line segment BC, then we find the midpoint, and we draw in a segment that's perpendicular to that, as indicated by the right angle symbol. We have a perpendicular bisector of a segment. So two things have to be met, two conditions. It has to be perpendicular, and it has to go through the midpoint of a line segment. So if a point is on the perpendicular bisector, of a segment, then it is equidistant from the endpoints of the segment. That means that up above, since we have point A that's on the perpendicular bisector, that means that point A is equidistant from the endpoints of line segment BC. That tells us that AB is equal to AC then. Now the converse of the perpendicular bisector theorem says if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. So this works two ways. If you can show that a line segment is perpendicular to another segment at its midpoint, then the distance from the endpoints will be equal, and vice versa. If you show that those distances are equal, then the point has to be on the perpendicular bisector. Okay, so a couple of quick questions here. It says find the length of line segment AB. Okay, so first thing you want to do is check to see that you have a perpendicular bisector. So this line segment is coming in, it's definitely perpendicular. We see the symbol, and it's definitely going through the midpoint because those two pieces are marked congruent. So that means that point A has to be equidistant from the endpoints of BC. So that allows us to set 2x plus 19 equal to 5x plus 7, and then we could solve for x. I would probably take and subtract 2x from both sides just so I keep the x's positive, and that's going to give us 19 equals 3x plus 7. Take and subtract 7 from both sides, and 19 minus 7 is going to give us 12, and that's equal to 3x. Divide by 3, and we get x is equal to 4. But remember, there's a follow-up question. We have to find the length of AB. So recall that in this particular one, AB is equal to 2x plus 19. So you have to do 2 times 4 plus 19. So 8 plus 19 gives us a total of 27 for AB in this particular case. All right, and the second problem, again, we have to do the same thing. First, verify that this line segment is perpendicular and that it bisects line segment AC. And those two conditions are met. That means that the line segment AB is congruent to BC. So we can set 6x plus 17 equal to 4x plus 25. So take and subtract that 4x from both sides. We get 2x plus 17 equals 25. Subtract 17 from 25 to get 8. Divide by 2, we get x equals 4. I wrote x equals x. Okay, so since x is equal to 4, now we can come back in and solve for AB. We want to do 6 times x plus 17. So AB equals 6 times 4 plus 17, or 24 plus 17. So AB is equal to 41. Final answer. Okay, that's it for the notes. Give homework number 8 a try, and as always, see me for extra help if you have questions.